Welcome today to this Researcher's Desk lunchtime session. It's nice to see lots of people dropping in. Today we have the honor of welcoming David Ramsden to join us today. And just a couple of words from me about David. I ran into David a little bit by random, actually to do with some of his singing. And David kindly invited me to one of his talks he was giving for a local community in England. And I was super impressed. And that's why I want the Researcher's Desk to come and listen to David. David is not a climate scientist, but he has respectfully read up masses of papers. So you'll be super impressed by the research that's gone into this talk. The talk is going to take most of the lunchtime session, so there won't be an awful lot of time for discussion. But I'd like the Researcher's Desk to support David by providing him afterwards some constructive feedback, what you thought was good about the talk, where you thought it could be improved. As David talks to lots of people in the UK, and often people who are not at all interested in the climate crisis. So he's helping a lot of people work out what to do and how to solve the crisis. So do take a couple of minutes to jot down a few notes, email them to me straight after the session, and I'll compile some feedback for David. Because as I say, there won't be a lot of time for questions as David's talk it will take most of the lunchtime session. So I think that's enough for me. David, you are warmly welcome to the Researcher's Desk. Thank you for spending your lunch with us. The floor is now yours.
Well, thank you very much indeed for that introduction. So I shall crack on. In fact, before I do, I'll just mention briefly that in the middle of the title slide that you can see, there's a little bit of grey text that says life seems pretty normal, which you might just be able to make out. As we go through the presentation, you'll see that I've put dark grey text on most of the slides. It's there not for you to read, but it's there to remind me what to say sometimes, and also provides the source of the information that I'm giving. Okay, so first of all, a bit about me. There's me in the middle of the picture sitting on my mother's knee. So my parents moved into a new bungalow when I was a baby in 1959, and the house was completely powered by coal. Our electricity was made from coal, our gas was made from coal, and we burned coal as our only source of heating in the home. Both my parents were teachers, and it turned out that my career was not a career. I've had a vocation in nature conservation. I started public speaking in 1989, and I've been slightly aware of the climate situation for many, many years. But I became very aware of the situation with the publication of the 6th mass extinction paper in 2017, and then the IPCC 1.5 report in 2018. So I spent the winter 2018-2019 reading a lot of papers and reports, and then decided that what I could do is actually start talking more about the climate and ecological crisis. So my work in nature conservation was recognized by a presentation of a medal. But I should say from the outset that I'm not a climate scientist. I don't have all the answers. So let's crack into the talk now. First things first. Habitable planets are really hard to find. In the universe, we've identified 1 million billion planets, and we've only found 2 with an atmosphere and water, and they are Earth and K2-18b. And just in case you were thinking that one day we might live on K2-18b, it would take 111 years to get there at the speed of light, and may turn out to not be habitable anyway. So we really are dependent on planet Earth. In order to carry on living on planet Earth, what do we need? Well, Earth is only habitable because it has a balanced climate system. And scientists divide that climate system into 5 component parts. There's all of the frozen fresh water named the cryosphere. And that helps to stabilize our climate system because of the sheer size of it. The sheer amount of cold material in the system has a kind of air conditioning effect. And it also reflects a lot of the incoming solar radiation from the sun, which helps to stabilize our temperature. And then there's the geosphere, which is basically the soils. Without soils, we wouldn't have plants. Without plants, we wouldn't have our atmosphere as we know it. And of course, plants depend on water. So the evaporation of the oceans, rain falling, rivers, lakes, etc. And also, of course, the hydrosphere is largely the oceans, the way that currents move around the oceans distributing nutrients, the way that supports algae, which provides a lot of our oxygen, and the ecosphere, of course, both on land and in the sea, we are completely dependent upon. And in fact, it was the ecosphere that created our atmosphere and our climate system in the first place, certainly the climate system we know, and of course, the atmosphere itself, a good balance of atmospheric gases that not only we can breathe, but insulate us appropriately from surrounding space. So think about it. If we lost any one of those, Earth would become uninhabitable. But hang on a minute. The Arctic and the Antarctic are still frozen, crops still grow, it still rains, we still have lots of wildlife, and we can still breathe. So what's all the fuss about? Well, if you start to look at any of these in detail, you find that ice is disappearing from planet Earth, and that loss is accelerating. Crops do still grow, but crop failures are increasing. It certainly still rains, but droughts are on the increase. We still have wildlife, but wildlife has been in decline for many years, and globally that's accelerating. Fish stocks are low, mostly crashed or fully exploited and in decline. We can still breathe, but actually air pollution is already killing approximately 8.7 million people every year. Why are these things happening? Well, there are various reasons, but first of all, we're going to talk about the climate crisis. To understand the climate crisis, you need to know something about carbon. Your body is 18% carbon. A typical tree is about 50% carbon. There's been complex life forms on Earth for about 500 million years, and trillions of tons of life forms have died and eventually become fossilized, and those fossils contain the carbon that was in them when they lived. And these days we call those carbon-rich fossils fossil fuels because we pump them up or we dig them up and we burn them. Burning fossil fuels releases the carbon, and that enhances something called the greenhouse effect. The greenhouse effect is natural. Without a greenhouse effect, the average surface temperature of Earth would be minus 18 degrees centigrade. So we need the greenhouse effect. And the way it works is basically solar radiation comes in from the sun. A lot of it is re-radiated by the planet's surface, and the upper gases in the atmosphere, the greenhouse gases, trap some of that re-radiated heat and help to keep our planet warm. What we've done, of course, in burning fossil fuels is we've added more of the greenhouse gases, principally carbon dioxide, but also methane and nitrous oxide, and this has trapped more of the solar radiation, and hence the temperature's gone up. So in 1880, the average temperature of the surface of the planet was plus 13.7 degrees centigrade, and last year it was 14.9. So it's gone up by about 1.2 degrees centigrade. Okay, so the world's a bit warmer. What does that mean? Well, it turns out that the climate system is very, very sensitive. You only have to increase temperature a little bit before major things start to happen. For example, you get more storms and you get more floods. You also get more ocean acidification. Now, that's not strictly to do with the warming. That's because a lot of the carbon dioxide that's increased in our atmosphere has been absorbed by the oceans, where it becomes what's called carbonic acid. And if you're a shellfish trying to grow a shell, that's important. So there's already evidence that shellfish are having difficulty growing their shells. It takes them longer, etc. That's important because most ocean food chains involve shellfish. Obviously, in a warmer system, you're going to have more droughts, you're going to have more heat waves, and therefore you're going to have more wildfires. So small changes in temperature can have really big results. The world's a bit warmer, but what about all the cold weather we've had, particularly in the northern hemisphere? So to understand this, I need to introduce you to the jet stream. The jet stream is a narrow band of strong wind that blows around at about the same height that jet aircraft fly, about 36,000 feet. And it's driven by the temperature difference between the poles and the equator. There's a similar jet stream in the southern hemisphere. And it has the effect at ground level of separating the colder Arctic air from the warmer tropical air. What's happened when we say the planet has warmed by an average of 1.2 degrees C, it hasn't warmed evenly. The Arctic has warmed 2 to 3 times as much as the average, and that's reduced the temperature difference, which has reduced the driver for the jet stream. As a consequence, the jet stream has slowed down. It now meanders. It can go a long way north or a long way south. It's slowed down, and sometimes it blocks changes in our weather. In this graphic, the jet stream is shown as a series of brown arrows. And what can happen is the overall motion of weather systems from the west to the east can stop. And if it happens to stop when your area is in cold polar air, then you can have very, very long-lasting cold weather. Here in the UK, we called one of those the beast from the east. That was in 2018. In fact, in 2013, in the spring, it was even colder, the coldest spring since 1963. And conversely, that overall movement to the east can stop when your country is in warm tropical air, and hence you can have a long-lasting heat wave. The jet stream is also fragmenting. So here in pink, you can see little bits of the jet stream in different parts of the northern hemisphere. And so really, it's nothing like the jet stream that we used to have. So our weather has become very unpredictable. Okay, so what about the floods we keep getting? Recently, of course, in Germany, Belgium, and Luxembourg. Here in the UK, we had a tremendous one called Storm Dennis in February 2020. The oceans have not only absorbed most of the carbon dioxide we've added to the atmosphere, they've also absorbed most of the heat energy, over 90%. And warm water evaporates faster. So we get more water going up to form clouds, clouds holding more water, and that causes extreme rainfall events when that cloud comes over land, and hence more rainfall related flooding. So let's have a quick recap. Loads of CO2, carbon dioxide, has gone up into the atmosphere. That's warmed the planet by about 1.2 degrees, but the Arctic has warmed more than twice as much, which has changed the jet stream, which makes extreme weather more likely, sometimes makes the weather we get last for longer, and the sea is warmer, so we're likely to get more rain and more storms, and polar ice is melting. Warm water expands, so the seas are rising. We'll talk about that in a moment. Okay, so you're with me so far. Fantastic. But hang on a minute. Carbon dioxide levels in the atmosphere have always gone up and down. It's natural, isn't it? Well, yes, they have always gone up and down. If we look at the last 450,000 years, we can see that it's gone up and down in relation to the ice ages, which are the low points in this graph, and the interglacial warmer phases, which are the higher points. And if we just look at the top, we look at CO2, the carbon dioxide concentration, we can see, looking below, that it's actually very closely linked to global temperature and sea level. And in the top right-hand corner there, you can see how in almost no time at all, the CO2 concentration has shot up. So it kind of stands to reason that it's likely the temperature is going to shoot up and the sea level is going to shoot up as well. And here in England, we're extremely concerned about that because we have quite a lot of low-lying land. My hometown in the southwest of England is going to be flooded, but in the next 29 years. These flood maps are from the Climate Central website, and they are 2050 flood maps. And sea level rise is very predictable compared to other outcomes of warming the planet. So these flood maps are actually very dependable. So we're looking at major flooding in other parts of the world as well, such as some of the Pacific Islands may disappear, Bangladesh, etc. So let's look at the effect of possible CO2 in the next emissions in the next 80 years. Now, you'll be familiar with climate modeling, but computer modeling is not something that's peculiar to climate science. It's used in so many different areas these days. It's used in the design of the brakes that are in your car. It's used in predicting pandemics, for example. So computer modeling is not something peculiar to climate science, but it is used by climate scientists to predict what's going to happen in the future. And in order to run their models, they need to know what the emissions are going to be in the future. And of course, they don't know. So they create what's called representative concentration pathways. And that's what you can see here in the graph. So that red line, for example, represents very, very high carbon emissions. The gray line, a lower rate of emissions. And you can see there the temperatures that those emissions would lead to within the next 79 years. So that's basically temperature this century. And the figure there is the range within which the mean increase would happen for the whole of the planet. Of course, it wouldn't warm evenly. Well, if we get a temperature increase on average of between 3.2 and 5.4 degrees centigrade, then we can be certain that that's enough to wipe out most life on Earth. We know that from previous mass extinction events as recorded in the fossil record. We might have a lower trajectory with our emissions and end up with a temperature increase in the range of 2 to 3.7 degrees. That's almost certainly enough to wipe out civilization, because it is enough to cause massive crop failures. With massive crop failures, multi-breadbasket failure, we would see mass starvation and mortality. We would see mass migration, and the combination of starvation and migration would destabilize political boundaries and very likely cause wars and the loss of law and order, and no doubt the collapse of society in many parts, possibly the total collapse of civilization. So that's not a good idea. If we have that yellow trajectory with our emissions, we'll see more of the impacts we're already seeing. And climate scientists agree, and many politicians, that where we need to be is below carbon neutral by the latter half of the century following that blue line. There is hope, because in 2015, a fantastic thing happened, which was the Paris Agreement, which you've probably heard of. That really was a huge achievement, because governments agreed to keep the average temperature increase to below 2 degrees centigrade, ideally 1.5. But what have the countries in the Paris Agreement actually pledged to do? Well, here we are with a similar graph, and you can see the red line leading to most life wiped out and the blue line leading to where we need to be. And in between the two is that black and white dotted line. That is what would happen with our emissions if all of the countries do what they said they were going to do in the Paris Agreement. In other words, the country pledges are not, as they stand, strong enough to meet the 2-degree target. They are good, but they're not enough. Okay, now the bad news. That is where we were heading with our emissions in 2020, above the red line. How do we know that? Well, we know how much carbon and carbon equivalent we emitted in 2018. We know how much we emitted in 2019. We could be pretty certain it was going to be 44 gigatons in 2020, but then along came COVID-19 and we saw a temporary reduction of about 7%. But we are pretty much fair and square on or slightly above that red line. And if we carry on as normal, basically life as we know it will be over. It's just a matter of time. The IPCC, the Intergovernmental Panel on Climate Change, total 3,750 of the world's best climate experts and representatives of all the different nations. They say what we need to do starting in 2020 is to reduce our emissions to zero by 2050 from that peak of 44 gigatons that we would have reached last year. That's a reduction of 7.6% every year. And even if we did that, it would only give us a 50-50 chance of limiting warming to 1.5 degrees C. And that is why 2050 is too late. Well, at least it's one of the reasons why. There are other reasons why 2050 is too late. But it's the urgency and the fact that we should have started last year. That's why protesters are saying we need to act now. It's an absolutely massive challenge. And according to the Secretary General of the United Nations, if we fail to sort this out, we are facing total disaster. It's also a massive challenge because the world leader, both in emissions and historically, and in policy, hopefully to tackle this, backed out of the Paris Agreement for the 4 crucial years running up to 2020. And Australia, the world's biggest exporter of coal, is determined to maintain its production. And here in the UK, we're not on track to meet our own emissions reduction targets, according to the government's own Committee on Climate Change. It's also a massive challenge because the amount of gas and oil being used to produce our energy is still increasing and makes the amount of energy coming from the renewables look absolutely tiny in comparison. You can see there at the top of the graph, the renewables sections. Which energy source received the most investment in recent years? Fossil fuels. Which energy source grew the most in recent years? Fossil fuels, according to the International Energy Agency. Well, now let's have something completely different.
The earth has warmed 1 degree, that's increased the level of the sea. Warming makes the sea expand, it rises up and floods the land. At 2 degrees you can kiss goodbye to Miami and Shanghai. There's 20 million people there, who has that many rooms to spare? By 3 degrees glaciers have gone, with less polar ice to reflect the sun. Refugees will then exceed 250 million. At 1 degree, no surprise, half our coral reefs have died. Such a rich ecosystem, 500 million people depend on them. At 2 degrees, I tell no lie, lots more coral reefs are sure to die. Corals bleach to a ghostly white, it's happening almost overnight. By 3 degrees, they will all be dead, gone with the life they supported. They'll never ever grow again, you see, with rising ocean acidity. At 1 degree, land gets hot, though you might think that 1 is not a lot. Extremely hot days per year increase to 4 or 5. At 2 degrees, farmers struggle, food supply is really in a muddle. average 27. By 3 degrees, the weather's gone mad. Food is scarce, things are looking bad. Extremely hot days per year will average 62. We've warmed the earth 1 degree. Signs are here for everyone to see. We must make sure we don't hit a major tipping point. There is a risk we can detect of triggering a domino effect. If that occurs, there'll be no way of stopping climate change. If we don't act decisively to combat warming urgently, on our present trajectory, we're heading for 3.2.
So just before we go on to talk about the ecological crisis, I'll just give you a quick update to the song. The song was written in 2018 and ended by saying we're heading for 3.2. And at the time, that was the average of all projections. Scientists today are saying typically that we are heading for 4 degrees of average warming by the end of this century. The song also introduced tipping points, which I didn't mention previously. And there are 9 tipping points identified in the climate system. And out of those 9, there are 15 tipping points been identified in the climate system. And out of those 15, 9 are already active. And some scientists are saying that the loss of Arctic sea ice has already passed its point of no return. And basically, we're going to lose Arctic sea ice now, no matter what we do. So let's move on now to talk about the ecological crisis. You've seen this graphic before. And the key part here, of course, when talking about the ecological crisis is the ecosphere. All human life exists within the ecosphere. And with the exception of solar energy and some of our minerals, the ecosphere supplies everything we consume. Certainly all the living things that we consume come from the ecosphere. Within the ecosphere, our population is growing, currently at about 7.8 billion and still growing. But the ecosphere itself is not growing. It can't grow. And the biologically productive part of the ecosphere is around 6% of the ocean and 18% of the land. So that's 24% of the planet's surface. And that 24% equals 12.3 billion hectares. If we divide 12.3 billion hectares by 7.8 billion people, we can easily see that we have 1.6 hectares of land per person. That's Earth's biocapacity. But we don't live within Earth's biocapacity, or at least many of us don't live within it. We're actually using on average 2.5 hectares each. That's our ecological footprint. And that's why you hear some scientists say that in order for life on Earth to be sustainable, we would need the resources provided by 1.6 planet Earths. Of course, we only have one planet Earth. And it's because of the size of our ecological footprint that we are basically in the situation we're in. Our population size and our overconsumption is temporarily being propped up by releasing the energy stored in fossil fuels, not just for our transport and our heating, etc., but also the nitrogen fertilizer that farmers are using to grow our food. That's a fossil fuel as well. So we release fossil fuel energy to prop up our consumption and our population. We destroy more and more natural habitat, the obvious example being the tropical forests, which are never replaced. And we allow our waste to accumulate in our environment, which on the face of it sounds rather disgusting, but that's what we do. And the greatest part of that by weight is carbon dioxide. As a consequence of this, we are now well and truly in the 6th mass extinction event. So there have been 5 previously on Earth. The last one, 60 million years ago, was the loss of the dinosaurs, of course, which is the most well-known mass extinction event. But we're now in the 6th one. And currently, the rate of extinctions is a lot faster than the average rate of extinction. Up to 1 million species currently face extinction. And the loss of species and habitats poses as much danger to life on Earth as climate change. That is quite a staggering statement. That comes from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. That's the biodiversity equivalent of the IPCC. It's the world's best scientists are basically saying, even if climate change wasn't happening, we are still up the creek because of the loss of species and habitats. What does Sir David say? Wow. Okay, so here in Britain, a lot of people say, well, that's fine, but actually Britain is not emitting very much CO2 compared to countries like China. Go and talk to China. So I have to explain to people why Britain should take the lead. And there are lots of good reasons why we should. For example, 2 of the biggest fossil fuel companies in the world happen to be 40% British owned. That's a pretty good reason. And here in the UK, we give the fossil fuel industry more money than any EU member state, which is quite an incredible statistic. Per person here in the UK, we emit only slightly less than a typical person in China. And let's face it, we started it. The Industrial Revolution, based on the burning of coal, began here in England. Oil companies spend a fortune on trying to prevent policies being brought in to tackle climate change. And guess who the worst offending companies are? They are the 2 companies that are 40% British owned. So there are some very, very compelling reasons why the UK should be taking the lead in tackling climate change. Let's have a quick look at denial. Scientists have researched denial in a similar way to the way they search anything else. And they've identified 5 techniques that the denialists use. And the first is called fake experts. So this is basically creating the illusion that there's an ongoing scientific debate about whether climate change is actually happening and whether it's caused by man, using people who are pretending to be experts on the subject. And then there is the habit they have of using red herrings. This is throwing confusion into lines of argument to basically put people off the natural conclusion or jumping to the wrong conclusions, demanding unrealistic standards of proof or claiming there's not enough evidence, just looking at small amounts of the evidence rather than considering all of it. Cherry picking is a very popular one. And if at the end of the day the denialist is losing the argument, then the ultimate thing is they will claim that all of the scientists are just in a big conspiracy and they're falsifying the evidence. But in fact, that is all rubbish. The consensus among publishing climate scientists that humans are causing global warming is incredibly overwhelming. There really is no ongoing debate at all. But denial is very, very understandable. Personally, I don't think denial is black and white. I don't think you're either a denialist or a believer. I think denial is all shades of grey. Because if most of us were not partially in denial, how could we start the car, the diesel car, for example? Or how could we have a baby if we weren't partially in denial? Denial is very understandable. Don't feel bad. We just need to get over it. The science is absolutely clear and we know what we are facing. What we need now are solutions. Now, when we look at solutions, we tend very often to look at individual changes in behavior to tackle this global crisis. But what we need to do is to consider these solutions are not just individual, they are for communities, they are for countries, for the whole world to undertake. So first of all, let's just look at the big sources of emissions. Energy is responsible for about 2/3 of all greenhouse gas emissions. So the obvious solution to that is to use less. So for example, we need to insulate our homes more. We need to make sure that our energy supplier is 100% renewable. It's very easy to switch, particularly with electricity. We need to stop using the fossil fuels as quickly as we can. We need to ditch our natural gas boiler, for example, and get a heat pump, air source, ground source heat pump. You could start or join a local community energy group. And these are very successful. There are plenty of examples of how people have got together to save themselves money, make money, and actually reduce emissions at the same time. And importantly, we need to divest. We need to take investments out of the fossil fuel industry, and we can do that by moving our money between banks, choose an ethical bank, and also look at your pension fund. Oops. Okay, looking at transport, we can see that that represents 16%, and staggeringly, 73% of transport emissions come from short journeys. So what do we need to do? Don't travel on jet aircraft is one of the first things. We really need to stop that, because per person per kilometer, a full jet emits 10 times more emissions than a full car. Cruise ships emit as much as 1 million cars. So we really need to stop using these heavy emitting forms of transport. We need to stop buying diesel and petrol as quickly as we can. So we need to switch to the alternatives. We need to walk, cycle, use an electric cycle or an electric car. My partner and I bought our first electric car last year, and it's absolutely wonderful. We couldn't afford a new one, so it's secondhand and it's fantastic. Travel less, so use Skype video conferencing. There are lots of other things we can do to reduce our transport emissions. Food production is the single largest human pressure, and it's driving the 6th mass extinction event, and also accounts for nearly 1/4 of emissions. So what can we do? The first thing really is to eat a lot less meat. Meat production is a very inefficient way of feeding people and results in a lot of emissions. So switch to a plant-rich diet. A vegetarian, emissions will be reduced by 63%. And if you go the whole hog and become a vegan, you'll reduce your food emissions a little bit more. But more importantly, you're reducing your impact on the biosphere by reducing habitat loss and intensive farming. Eat locally produced food that's in season, organic to reduce pesticide use, grow your own, reduce waste, compost more, etc. Consumerism. We are in a terrible habit of buying things that we don't need, and that results in huge amounts of emissions. So what are we going to do? We're only going to buy what we really need. Who needs fashion goods, really? Fashion industry is responsible for huge amounts of emissions. Don't buy new things unless you really have to. So choose locally produced, sustainably produced, and things that can be repaired, things that can be reused, rehomed, and recycled. Let's have a think now about the way that we vote. In the democracies in the world, we tend to assume that our representatives are voting in the best way they can on our behalf. In the UK, for example, that's our MPs voting in the House of Commons. But here in the UK, the way that our MPs vote is actually a matter of public record. And if they have a weak record of voting on tackling climate change, they're on the left of this graphic. And if they have a strong record of tackling climate change, they're on the right. And look where the Conservative, the right-wing Tory MPs are. They have a really strong track record of not supporting measures to tackle climate change. So we need to address the way that we vote and make sure that we are supporting representatives who have their priorities right. And the last solution of all, something we can all do, is to talk about it. These crises are the elephant in the room. They are so often not talked about. So talk to people, talk about extreme weather events, the wildlife you don't see anymore, your concerns for the future. Talk about this presentation, talk about it more. What to do, what to expect if we do it all. So if we do all of the solutions I've mentioned and more, right, all of that, what we'll have is more time. I think realistically, given the amount of emissions that we've already done and the amount of heat already locked into the climate system, I think the best we can probably hope for is delaying the worst impacts and giving ourselves more time. And that means more time to adapt to the changes that are coming, no matter what we do, more of that precious time with our families. And if we do all of those changes, we will also be in better health, thinking about our diet changes and our cycling and walking. And we'll have stronger local communities, thinking about buying locally produced food, for example. The alternative to doing all that and tackling the problem is nothing. And nothing is the easiest thing to do. Just carry on as normal. That's all you have to do if all of these things are going to come to pass. That's all you have to do, carry on as normal. So carrying on as normal really is not acceptable. We have to change the way that we live on planet Earth. So now you know what all the fuss is about. We must act now for life on Earth and for the children. Thank you very much indeed for listening. And in a moment in the chat, I will post the 2 handouts that I provide at the end of these talks, either on paper if it's a talk in person, or as links, which I shall shortly post in the chat. So there you are. Thank you very much indeed for listening.
Thank you very much indeed, David, for that very, very impressive talk. You actually were faster than you said, which means that there is actually time for people to ask questions. So I'm going to be looking at the chat right now. And as I said at the beginning, for those of you who dropped in a little later, David's giving this talk in the UK to lots of communities. And I would really, really appreciate any helpful, constructive comments that you make sure you send an email to me. I'll post my email in the chat so I can compile a letter to David so we can be as helpful and supportive as we can. Anyway, it's now over to people. As you see, David, there's lots of incredibly positive words coming through in the chat right now. I don't know if you can see that. But if you want to ask a question, either put your hand up using the Zoom function, or write down in the chat. So just to give people time to think of